Chapter 3 is focused mainly on fractions and decimals, and we're going to start today by working with fractions. You did learn operations with fractions last year, so some of this may be a review. Take a minute to write down the target. If you need to pause the video to get it all written down, you can do that right now. So fractions are really important in the world. They're used in a lot of different aspects. Take a look at this example. We can think about money and change as a fraction of a dollar. A quarter is 1/4 of a dollar. Fractions are also important whenever when you're cooking, when you're following a recipe, if you wanted to double the recipe or maybe you wanted to halve the recipe. Fractions are also involved in measurements. If you think about in architecture, if we wanted to make the master bedroom twice the size as one of the regular bedrooms, we would use fractions. If we want to make one of the bedrooms a third of the size of the master bedroom, we could use fractions as well. And then also, there's another example with price. You think about sales. So fractions are used a lot in the world. If you think of any other examples that are used, jot them down because it's a good thing to kind of reflect on. For the warm-up, I want you guys to try simplifying these fractions. Remember, when you simplify, you're thinking, what can I divide out of both? So try these 3 problems. And one thing I want to note here, when you have a negative in front of the fraction, that's the same thing as negative 15 over the 25. You can push that negative in the numerator, or you can push the negative in the denominator if you want. I prefer to put it in the numerator always just to be consistent, but what it's not the same as is if you give each one its own negative. This is going to be a very different answer because a negative divided by a negative would make a positive, and that would cancel out the negative. So you want to make sure that you write it one of these 2 ways. I always put the negative in the numerator whenever you see one out front. So what can we divide out of both of these fractions? Well, we have 15 and 25. They both end in a 5, so we can divide 5 out of both. You want to show your teacher your work, so divide the fraction to reduce or simplify. Negative 15 divided by 5 will give you negative 3, and 25 divided by 5 will give you 5. Check to see if you can divide anything else out. 3 and 5, is there anything that I can divide out of both of those besides 1? 3 is prime, in fact, so is 5, so that's as far as you can take it. Pause the video now, try B and C on your own. When you're done, press play. For simplifying B and C, your steps may look different for B. You might have taken out a 4 at first, or maybe you knew right away that the 16 would come out. But if you take something out and you still have to check if the fraction is able to be reduced. So notice here, I took out a 2 from both, but that left me with 8/40ths, so I knew I wasn't done yet. And then I could take out an 8, and that gives me 1/5. And for C, a fraction may not be able to be reduced. It may be simplified already. With this last example, 29 is a prime number, so no number is going to go into 18 that you could take out of both 18 and 29 besides 1, so that's as far as you can take it. It is simplified. We're going to start today with focusing on adding and subtracting fractions, and these are the rules that you need to write down on your note guide. So when you're adding or subtracting fractions, you always want to find common denominators first. Today, we're just going to focus on fractions that already have the common denominators. But we will do a lesson on adding and subtracting fractions with unlike denominators later on in this chapter. After you have those common denominators, you want to add the numerators and keep the denominator. If you're subtracting, then change the minus to plus a negative and just, again, add the numerators and keep the denominator. And then whenever you're done, always check to see if you can simplify. So ask yourself, is there any number I can divide out of both the numerator and the denominator evenly? One thing to note is it helps us if we convert mixed numbers to improper fractions always. So always, always, always do this. You may want to write this down over here if this makes sense to you. The way you would convert is you always take the whole number and you multiply it by the denominator, and then you add the numerator to it. So you would have the whole number times the denominator, and then you add the numerator, and that's all going to be over the same denominator. Doesn't change. So let's try this here. We would do 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 + 3 = 8. 5 × 4 and that's over 4. 5 times 4 is 20. 20 plus 3 is 23. So the improper fraction for 5 3/4 would be 23/4. Try the next one. Again, multiply and then add. One note here, when you have a negative, I want you to just put it on your answer and then ignore it. If this whole number is negative, then that whole improper fraction will be negative. So move the negative to the answer, and now I just want you to do this regularly. You already took care of the negative, so what is, cover up that negative. What is 2 times 8 plus 7? And you're going to keep that denominator. So 2 times 8 is 16, plus the 7 is going to give you 23. And you keep the denominator, so it's over 8. And again, if this number is negative, so will the improper number be negative. So always, always, always convert mixed numbers to improper fractions before adding, subtracting, multiplying, and dividing. There are some problems in which you don't need to do this. However, I think it's easier to just be consistent and always solve the same way. So let's make this a habit that we always convert first. So try A, B, and C. We want to try these 3 numbers, these 3 problems of examples of adding or subtracting fractions. The first one, we have 7/10 plus m, for m being equal to 3 1/10. So since we know what m is, we can substitute it in. We would have 7/10 plus the 3 1/10. Again, just like we saw, it's going to help us if we make the mixed number an improper number, so let's do that. We would have 7/10 plus 3 times 10 is 30, plus the 1 is 31/10. Now we have a common denominator, so our rule was you add the numerators, keep the denominator. Add the numerators, keep the denominator. And our last step would be to reduce, so simplify it down. What can we take out of both of these? If you're ever unsure, always look for, hey, are they even? Because you could take out a 2 if they're both even. Here they are both even, so let's take out a 2 first, and then we'll see if there's anything else to take out. 38 divided by 2, well 30 divided by 2 would be 15, and 8 divided by 2 would be 4. So put that 15 and that 4 together, 38 divided by 2 is 19. 10 divided by 2 is 5. Check, can we reduce it any farther? 5 is prime and 19 is prime, so we cannot. The last thing you could do is convert it back to a mixed number. Your teacher may or may not be particular about this, so you may want to ask them. But if you're given a number in mixed form, you should give your answer in that form as well. So 5 fits into 19 how many whole times? 5, 10, 15, that's 3 whole times. And your remainder is 4, and you keep the denominator fits. On the next one, the numbers are already lined up. We already have a common denominator. There's no improper, or there's no mixed numbers, so we're good to go. But I see this subtraction sign, and remember, when you see a subtraction sign out front, where can you put it? Put it up with the numerator, or you can think about changing it as to plus a negative. So this is really negative 2 ninths plus negative 5 ninths. Add the numerators. What's negative 2 and negative 5? Negative 2 and negative 5 is going to give you negative 7. Keep the denominator. Negative 7 ninths. Can you reduce it? Nope, that's as far as you can take it. Try this word problem on your own, then press play when you're ready to see the answer. Alright, so for the Permane brothers example, hopefully you like Permanes. I love those French fries on that sandwich. If they have 48 2/3 pound of potatoes and they're using 39 1/3, you would be subtracting. It will help you if you convert them to improper numbers and then subtract the numerators and then turn it back into a mixed number to get 9 1/3 pounds of potatoes. I'm going to stop here. You're going to go on to the next part of the video to get the rules for multiplying and dividing.